This time, we're going to try a hard LeetCode question named trapping rainwater. In this question, you are given n non-negative integers representing an elevation map where the width of each bar is 1. And you need to figure out how much water will be trapped after raining. There are two constraints you need to be aware of. N is within 2 times 10 to the 4th, and the height is within 10 to the 5th. Even though this question is categorized as a hard LeetCode question, the solution to it might be easier than you have imagined. Let's start with some observations on a given example. In this example, we realize that the water will be trapped if some spaces are blocked by the left and right blocks, like this guy, and this guy. And if you look closer, you will realize that the water trapped can be calculated independently. What do I mean by saying that? If you look at this water block, we know that the amount of water being trapped here is 1. But how do we get this value of 1? It is because the left block has a height of 1 and the right block has a height of 2. Water being blocked here is just a minimum of these two values, which is 1. Now, how about this block? This water block has a value of 1. But how do we get this value? It is because the highest left block has a height of 2, and the highest right block has a height of 3. The minimum of these two values is 2. But remember that we also have a block at this position. Eventually, you only have 1 unit of water being trapped here. Following the same logic, we can know that the water being trapped at this position is 2, and this position is 1. And lastly, for this water block, we can use the same logic. The height of the blocks surrounding it are height of 2 and height of 2. Now, the minimum of these two values is 2. We also need to subtract it by the height of itself, which is 1. Eventually, we got 1 unit of water trapped here. Now we know that for each position, we need to know the highest left block and the highest right block. We need to find out their minimum, and we need to subtract the value by the height of the current position. Now, how can we do this efficiently? If we do this calculation for each position independently, then we need to spend all the time looking at all the values from the left and all the values from the right, which will result in an n to a square complexity if we need to look through all the positions. This is an n squared complexity, which is not good. The direction you want to head for is to reuse the information that we have learned from the previous calculations. In fact, the maximum left bar for this position can be transferred to this position by just doing a maximum with this value. Basically, we just need to go from left to right, and then we will know the maximum height of all the left blocks. We also need to do the exact same thing from right to the left. This is for the max left height. This is for the max right height. Once we have these two key informations, then we can loop through the array again and figure out the water will be trapped for each position. That's basically how we want to implement the solution. Now let's jump into the coding part. As we mentioned earlier, there are mainly 3 parts in this code implementation. The first part is to find the highest block from the left. We also need to find the highest block from the right. Eventually, we need to aggregate the results. Before we start, I would like to first know the length of the array. I'm going to assign it to a variable called n. Now, to know the highest block from the left, I will need to have an array to keep the values. So I'll default everything to 0 for the whole array. I also need to maintain the max value, which I will default to 0. Now, I will go through the whole array from left to right, and I'll keep updating this max value. I will compare that with the height at index. And eventually, I will assign the max value to each location in the boundaries. Note that the order of these 2 lines matters, so that the blocks that are boundaries for others can also be calculated correctly later. For example, this block of height 3 should have both the left boundary and right boundary equal to 3, so that no water will be considered trapped here. It is similar for the second part. I can mostly copy the code here and paste it here. except that it should be called right boundary now, and the order should be from right to left. And this should be also right boundaries. Here we actually calculate how much water is being trapped. Again, we need to look through the array. Now, the water being trapped here, we should assign it to a variable equal to 0. The water being trapped at each position can be calculated as minimum of left boundaries at index and right boundaries index. The minimum of these two values minus the height itself. Eventually, we'll just return this variable, trapped water. And now let's see if it works. It seems that it passes all the test cases, and now let's do the submission. Awesome. So you see the performance is pretty decent. And that's the end of this video. Thank you for watching.